talking about trapezoids. 6-6 is called trapezoids. We need to learn a whole lot about trapezoids. So the first thing you need to know is what one is. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Notice I wrote exactly in really big letters. Exactly one. That means not two. It means one. So you can't have two pairs of parallel sides. You have to have one pair of parallel sides. So that means they would look like this. There's two examples of trapezoids. They don't have to have these parts over here, these two sides that are not parallel, do not have to be the same length. They can be, they don't have to be. But you have to have exactly one pair. Question?
So you can have like two.
You cannot have two. As a matter of fact, let's make that very clear. Okay? This is still a trapezoid. This is not. Circle slash no, 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 no. Because there's two pairs of parallel sides. Two pairs of parallel sides make it what kind of figure? Parallelogram. So a parallelogram isn't a trapezoid. Okay, a trapezoid is not a parallelogram. So this one is not. Okay, they follow slightly different rules. Okay, but we have some rules for trapezoids, and that's what we're going to talk about today. Okay, so as long as it has one and only one pair of parallel sides, then it's a trapezoid. Okay? All right? And if you don't draw all these pictures, it's not a big deal as long as you get it that parallelograms are not. Okay? Give you a little bit of time to write and be caught up. All right, now do keep in mind if for whatever reason you get behind, you can look it up online. Actually, if you didn't write down the website ever, write it down, DoughtyLCA.tk. And that's DoughtyLCA.tk. Okay, so if you never wrote that down, write it down. You go there, you go to the Geometry tab. The videos are under Learn from Home. So the videos are under Learn from Home, but the notes are under Notes. It's either class notes or student notes, but it's pretty obvious. It's not under the place that says Useful Geometry Videos. Okay, it's under Learn from Home. Okay, all right, let's move on. Trapezoids, just like I said, have exactly one pair of parallelograms. That means that parallel sides, sorry. Exactly one pair of parallel sides. Parallelograms are never trapezoids. Never trapezoids. Because why?
Because they have two pairs of.
Good, because they have two pairs of parallel sides. Trapezoids are never parallelograms. Okay? Works both ways. Squares are never trapezoids. Why are squares never trapezoids?
Because they're two parallel sides.
Two pairs of parallel sides. Good. Squares are never trapezoids. They're also parallelograms. So it fits under here too. Rectangles are never trapezoids. Same reason. Rectangles are really special parallelograms. Rectangles are never trapezoids. Rhombuses are never trapezoids. Never, 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 okay? Trapezoids are their own thing. One pair, exactly one pair of parallel lines. Exactly one pair of parallel sides. Okay? So, just so that you understand all that. Okay? I specifically wrote it that many times just so that you guys would really, 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 really get it. Never, 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 never. Okay, they're their own type of thing. Still writing.
Is there any symbol for trapezoid?
There isn't really a symbol for trapezoid, no. So we just would say trapezoid ABCD. Okay. So let's take a look at this one. There are parts of a trapezoid. Okay. So the two parallel sides are called bases, and the two non-parallel sides are called legs. Okay, so you have two bases and two legs. Even if I took the thing and I turned it on its side, the bases would still be the parallel sides. I don't know if I can get the whole thing with the words to, maybe I can. Let's try this. If I turn this, it's not going to do it.
That's rotating.
There we go. If I turn it,
Wait, what?
if I turn it, you can't turn it in your notes, but if you turn it, the bases are here and here, the legs are here and here. The bases are just the parallel sides, no matter which way this thing is turned. Bases, legs. Base doesn't mean bottom, okay? Base just means that they're the two parallel sides. So the bases are the two parallel sides, and legs are the other two sides. Okay, we're getting this vocabulary down so that the other things that we say today are going to make some sense. On a trapezoid, there are also base angles. The pairs, and they go together, the ones that you would consider a pair have to be part of the same base. Okay, well the base is actually the segment. The base angles are the corners that are the ends of the same base. So 1 and 2 is a pair of base angles. 3 and 4 are a pair of base angles. You wouldn't say 2 and 3 are a pair of base angles. Because they're two different bases. They have to be the vertices that are the endpoints of the same base. So 1 and 2 are a pair of base angles, and so are 3 and 4. Okay? So that's an important thing for you to know. If the legs of a trapezoid are congruent, then it's an isosceles trapezoid. Now I put a whole bunch of examples. You don't have to draw that many of them, but I have a whole bunch of them just to show it doesn't matter if it's turned sideways or upside. You know, even though this isn't technically upside down, a lot of times we think of it as upside down. No matter which way it's turned, it's still isosceles as long as the two legs are the same length. Okay? So just like in an isosceles triangle has two congruent sides. So does an isosceles trapezoid. And there's some very special traits about isosceles trapezoids that we need to learn about. So we're going to work our way through those things. So isosceles trapezoids has two sides congruent. Alrighty, just about everybody has it all written down.
Wait, what's the difference between all three? So we have to draw all three of them?
You don't have to draw all three. Just as long as you understand it, as long as it has.
Okay.
Right. I just drew a whole bunch of them just to make the point that that you can turn them sideways or upside down, and it's still isosceles as long as the legs are controlled. All right. So let's get a theorem about isosceles trapezoids. It's a trapezoid base angles theorem. Remember, for triangles we had a base angles theorem, so this one's the trapezoid base angles theorem. If the trapezoid is isosceles, like this one right here, then each pair of base angles is congruent. Okay? So if the trapezoid is isosceles, then each pair of base angles is congruent. picture, does anybody see one pair of congruent angles? Luke, what? Do you see a pair of congruent angles here based on this theorem?
1 and 4.
1 and 4. Okay, Alexis, what's the other pair?
2 and 3.
2 and 3. Good. So even though it's not just one pair, both pairs have some congruency. Okay? Angle 1 is congruent to 4 and angle 2 is congruent to 3. Remember, they go together as long as they're part of the same base. So 1 is congruent to 4, 2 congruent to 3. And that's only true if it's isosceles. If it's not isosceles, then that doesn't work. So these are very important. Honestly, we know that these two are parallel. Okay, so I guess to be a little more technically correct, we should have those little parallel symbols in there. But we have the isosceles trapezoid, legs congruent, so the base angles have to also be congruent in their pairs. Does that mean that 1 and 2 are also congruent? No. What actually would be the relationship between 1 and 2? Yes. Supplementary. Good. So they have to add up to 180. All right, here's a sample question. If angle A is 65, we need to find B, C, and D. Yes, you should write it down. And you should begin to think it through. And if you can write it down before we reveal it, that's kind of a good thing.
Oh, snap.
You can draw it right on the picture. Who can tell me what B is? Go ahead, Kendall. 65. Angle B is 65 because of theorem 6.17. Okay, these two base angles are congruent, so they have to be the same angle. Harry, can you tell me angle C?
115.
115. Good, Harry. How did he get that, Kendall?
You subtracted 180 and 65.
Good. Subtract 180 degrees minus 65 is 115. Good. And then that would make D how much, Alvin?
D would be also be 180. No. What? 115.
115. Good. Good. Yeah, I knew what you meant because you saw that one. So D is also 115 because of that. And have a good lunch, and I'll see you after lunch.
Wow.
Another thing about isosceles trapezoids is about its diagonals. If a trapezoid is isosceles, then the diagonals are congruent. So if a trapezoid is isosceles, the diagonals are congruent. So we have a couple of diagonals drawn into this isosceles trapezoid. So we need to so that means something. It means that the diagonals are congruent. So you can tell me what two segments have to be congruent in this picture. BD and AC. Good. BD has to be congruent to AC. Keep in mind that that is also true in rectangles. It's also true in squares. But they, as we know, are never considered trapezoids. But for trapezoids, the only way you get congruent diagonals is if you have an isosceles one. All right? Let's get that all written down.
Your dad's waking you up at 1 o'clock. Alright. I'm pretty sure
Okay.
your dad said it wouldn't be set.
Alright, so anyway, just about everybody has that written down.
Oh, I just said
Yeah, that those diagonals are congruent. And we'll move right along. Wait.
Wait.
Okay, wait. Almost everybody's got it.
yes.
Alright, moving right along. If the trapezoid has one pair of congruent base angles, then it's isosceles. You don't have to know that both pairs are congruent. You would be easily able to show that the second pair was congruent. But as long as one pair is congruent, then that shows that you have an isosceles trapezoid. So in this case, it works for these 1 and 2. It also works for 3 and 4. A lot of times people will easily identify these as base angles, but then forget that these are also base angles up here on the top. So just knowing that angle 3 and angle 4 are congruent tells you that you have an isosceles trapezoid. All right, so those are a couple different ways that you can actually tell that. And our next thing that we need to know is that if a trapezoid has congruent diagonals, then it is isosceles. It's really the converse of that other one we had. So we have a trapezoid here. In other words, if AC equals BD, then it's isosceles. So it's a good way of telling whether you have an isosceles trapezoid. Now remember, just like some of the other theorems, the value in that is because then you know everything else about isosceles trapezoids is true. It tells you what angles are congruent. It tells you that you've got AD congruent to BC. So it just tells you a whole bunch more information. So it's useful to know you have an isosceles trapezoid. Here it goes. All right, next one. Now this one's very useful. A midsegment theorem for trapezoids. First of all, we have the midsegment theorem. The midsegment of a trapezoid is parallel to each base, and the length is half the sum of the lengths of the bases. Okay, now all this down here is really, before we even have an example, telling you what a midsegment is. All right, a midsegment takes the endpoints from the midpoints of the two legs. So in order to draw one, you would actually, draw a trapezoid. It doesn't even have to be isosceles. You just draw a trapezoid. You'd put a midpoint here and a midpoint here, and then you would connect the line, connect it. So, that's how you determine a midsegment. Okay, the midsegment is actually just the segment that joins the midpoints for the two sides. All right, so FE is a midsegment for our ABCD trapezoid. The trapezoid does not have to be isosceles for this to work. Okay, this one almost looks like it's isosceles, but it doesn't have to be. Okay, it can be any trapezoid. Back on. All right, so this is nothing new right here. This is what you just wrote. This is the picture that you just made. Okay? This is what it means. First of all, it means that FE is parallel to BC. FE is parallel to AD. That's the first part of the midsegment theorem. It also says that if you add the two bases together and cut it in half, that gives you the length of the midsegment. So it's a formula. And here is the formula right here. So, you know, whenever there's a formula, it means we do problems with that formula. So really the only thing you're adding right now is this information right down here. Don't draw the picture back again. You're just adding, this is what it means. FE is parallel to BC, and FE is parallel to AD. So you add these, and you also can add these bases together, the lengths of them, divide by 2, and it gives you the other one.
Does that say BC or A?
That says BC. That says BC. So BC plus AD divided by 2 gives you FE. All right, we're ready for the next one.
Please, no. AD divided by
1. All right, so here's an example. Here we have a nice trapezoid. I on purpose made it not look isosceles so everybody didn't think they had to be. And we're given that AB is 12 and CD is 18. AB is 12 and CD is 18. Now this is actually the easier type of problem, and we need to find FE. You've already got it, Aaliyah, that's good. I'm glad that you already have it. For those that need to see it written, there we go. That's where it comes from. 12 here, 18 here. That mid-segment is 12 plus 18 divided by 2. Little simple math, simplify it, 15. Now some of those that you have the numbers and you're just trying to find the mid-segment are the easiest type. Do make sure though that when you do them on a test or quiz that you show your work, so just in case you make a mental math error and see what you plugged in. Okay, yes, question.
Would that mean that FE is like the average of the two?
Absolutely. FE is the average of the two. That's a good way of putting it, Kyle. And you're going to remember it because you just made sure you owned it. All right, good. All right, anybody still on this one? Okay, next one. Here's another sample problem. Now notice this is a little bit different. This time we're given FE, and we're given AB, and you're supposed to find DC. So you have to set it up just a little bit differently because you're given the length of the mid-segment, you're given this one, and you have to find this one. Now, what some of you may find actually is that this is way out of scale. It would, all right, so what do you think the answer is, Kendall? Is it 12 or 7? It is not either one of those.
What?
It is 1. Oh. All right, let's take a look at why. 9 is the mid-segment. Look, 9 is the mid-segment. Here are the two bases, 17 and an unknown. So 17 plus the unknown divided by 2 is the length of the mid-segment. If you multiply both sides by 2, you get that part simplified. Subtract 17, you get 1. Now, like I said, this is drawn horribly out of scale. It's drawn horribly out of scale, however. If this were truly the case, so we had 17 and 9, this would have to be 1. All right? Any questions? Nope. Okay.